Hey guys, lesson 510 is all about similar figures. This is an application of the proportions that we talked about in lesson 5.9. Today your job, your learning target, is to be able to identify corresponding sides in similar figures and then identify some equivalent ratios in similar figures. And then we're going to want to be finding the missing lengths or values in similar figures. The notes today are kind of basic, just getting you started. We will spend some more time in class looking at some examples, so let's dive in. Similar figures vocab review. Just a reminder that similar figures that are the same shape but not necessarily the same size, it maintains a ratio of similitude. That means a ratio of corresponding sides, where we're actually increasing or decreasing the figure by a scale factor. It maintains ratios within shapes. And then we have a statement of similarity that can be used with this symbol that you see right here. It's kind of like the approximately equal to symbol, but isn't two squiggly lines, it's just one. So as we take a look here, we are being informed that the triangle ABC is similar to the triangle XYZ. As we take a look at this, one of the things that we're going to need to be able to do today is to identify some corresponding sides. So as we take a look at what we call the ratio of similitude, it compares corresponding sides. Since both of these triangles are right triangles, there is one obvious pair of corresponding sides, and that's the hypotenuse, the diagonal side of the right triangle. The hypotenuses, that sounds about right, are always corresponding, meaning that the 10 and the 5 are a set of corresponding sides. As we take a look at the other two sides, the legs of the right triangle, we do have some corresponding sides there as well. One thing to look at is the indication of the length. There is a shorter leg on each of these right triangles, and the shorter legs would then be corresponding. So we can compare the small triangle to the large triangle in several different ways. The corresponding sides would be the corresponding shorter leg, 3 to 6, so 3 to the 6. And then we have the corresponding longer legs, which if we go small to large compares the 4 to the 8. And then we have our corresponding hypotenuse, which would compare small to large, 5 to 10. So each of those ratios is an equal ratio of similitude. They are all equal to 0.5. We also have ratios within the shape that would be maintained with similar figures. For example, we can compare the short leg with the hypotenuse. Oops, that should be SE, excuse me. The ratio comparing the short leg with the hypotenuse is maintained within similar figures as well. In the smaller triangle, shorter leg to the hypotenuse is 3 to 5. And in the larger triangle, the shorter leg to the hypotenuse is 6 to 10. This ratio is also maintained because 3 over 5 is equal to 6 over 10. They're both equal to 0.6. We can look at the comparison of the long leg to the short leg. If we look at long leg to short leg, we're comparing in the smaller triangle 4 to 3. And then we are comparing in the larger triangle 8 to 6. And both of these ratios or fractions come out to be the same as well. They both represent 1 1/3 or 1.3 repeating. So we're going to be looking at some examples in class when I see you next. You can try on your own to test your understanding. The big thing that you should be looking at is trying to identify some corresponding sides here. We'll be talking about the different ratios that would be maintained between these two similar figures and how we can then use those ratios to help us solve for a missing variable.